So I'm Lisa Michaud from Aspect Technology, and specifically I am the R&D lead for our natural language processing technologies. So that's the focus of what I'm going to talk about today. And one of the things I wanted to start with was defining what that means to a lot of people. They don't know. They know it's this thing. It's very popular right now. What does it mean? Well, it really literally is all about processing natural languages. And the distinction there that I'm going to make about natural languages is these are the languages that you and I and other human beings use to talk to each other. For the decades that computer science has existed, we have developed lots of artificial languages to talk to computers. And the great thing about this in artificial languages is that this means exactly one thing to the computer. It's unambiguous, and it will do exactly what you tell it to do. Of course, it is also not very accessible. I spent 13 years teaching people how to write this kind of stuff. What we really want to do is we want to be able to communicate with a machine using the languages that we use with each other. But these are a lot more difficult. So a very standard question that somebody might ask their home voice assistant would be something like, what is the weather? That question has a surface meaning and it has the real meaning. On the surface, it sounds like you're asking Alexa to define what weather is, which of course is not what you want, right? You want her to tell you what is the current weather, where you are at this moment. Or I might say something like, can I transfer some money from my savings account? On the surface, that's a question about whether you are capable of transferring money. But the reality is I'm probably trying to indicate that this is a use case I want to start. I want to get this going. So the difficulty of natural language is understanding not just what's going on in the words, but understand that human beings have all of these layers of meaning underneath what we say, which is very difficult. But I always say that's a good thing because that means I will have a job for a long time to come. But obviously it means that in order to do this, in any context, we need artificial intelligence. Now, there's as many definitions of artificial intelligence as there are people in this building right now. The standard ones often focus on the idea of imitating intelligent behavior, but beyond that, there's lots of specific definitions. Everything from we want the machine to be able to think, or we want the machine to have awareness of its own self. It has internal thoughts. Some people define it as we will have achieved artificial intelligence when machines have feelings. Some people say, well, as long as they can solve complex puzzles, that's what we need our AI to do. Some people say we'll define artificial intelligence as the ability to look at objects and recognize what objects they are. There are even people who say we will have achieved artificial intelligence when we can compose music with AI, which actually is already happening. Some people say, you know what, it doesn't need to do all those things. If it's at least as intelligent as a dog, and we say that dogs are intelligent, then a computer is intelligent. But if we go back to one of the earliest definitions of what AI is, go back to Alan Turing, he defined it as we will have achieved artificial intelligence when a computer can have a conversation, when computers can deal with natural language and participate in a conversation using natural language. So it really is a centerpiece of AI. And I don't really need to tell this audience why we need to move towards AI in the context of the contact center, right? We need a virtual agent because we need something that can be available all of the time. We need something that can work together with our human agents, not necessarily replace them, but supplement them, because computers don't get bored with the simple stuff that they have to do over and over again. The simple questions, the 100th person today to ask that question about whether you were open on Saturday. An AI can handle that question very easily and not get bored with it. It's a lot easier to have an AI that can handle multiple languages than it is to staff a human being that can speak multiple languages. And if your customer base is multilingual, you need to be able to cover that. And you can have something that will scale to contact volume, which means when nobody is coming in, we don't need to be paying for it. But when there's a sudden surge, it can scale and it can handle that. And finally, an AI is only a new employee once. So yes, when the AI is first deployed in the contact center, it will not be perfect. It has things it has to learn, it has to continue to be developed and worked on. However, there's no moving out and hiring a new person and having to start that training process all over again. You've trained it, it's there, it's going to stay. So why does a virtual agent need to have natural language processing? Why does it need to have this complex AI? Self-service has been around for a long time, but self-service in the voice channel, IVR, puts people in a situation where they have to listen to menu after menu after menu in order to get down to the use case they're trying to do. So they're listening to, please pay attention because our menu may have changed. For this use case, press 1. For this use case, press 2. And so on and so forth. Going into the text channel, a lot of people have created bots, as they call them, that basically are IVR all over again in the text channel. So asking you to respond with a keyword or a number, but keeping your responses very limited. Because in order to handle natural language, that's a lot more complex. That takes AI. What we really want is we want to have a virtual agent that can take in text input, which is in natural language, not responding to a prompt, not responding to a menu, but reaching out and saying, this is what I want to do. I want to book a reservation at this hotel. And we want that user to be able to take the initiative, which makes our job a lot harder because in the IVR situation, the first act that the customer does is make a phone call. And then it's the system's turn. The system has the first dialogue turn and can start with a question and put the user, the customer, in the job of answering questions. But in the text channel, that opening the connection is also a dialogue turn. You don't open the connection for communication and then wait for someone to talk back to you. You open the connection by sending text. So they have the initiative, which means they're not in the position of responding to prompts, which means they're not necessarily in a situation where you can constrain what they're saying by sculpting that expectation by telling them this is the kind of thing you can say to my system. They're just going to say whatever they want. But the advantage to that is minimal interactions. So if you're talking to an IVR and you have to go through a menu system, then each branch of that menu system can only have 3 or 4 or 5 possible options. And if there are lots of different things that your customer can do, it's going to take several layers of this interaction to get to the final step. But if they have the first turn and they can say anything at that initial step, it's possible that right there, they've already told you exactly what you need to know for what use case do they want to go into, what dialogue flow they want to enter, and you've already got yourself partway towards the resolution. So there are multiple things that are encapsulated within NLP that a virtual agent uses. Most of us focus on the side of natural language understanding. So this is the human being says something and the bot has to figure out what was in his or her head when that was said. What's the intent behind this? What's the meaning? If the bot is going to respond with something other than pre-made, pre-recorded sentences, then the bot has to be able to do generation, which is take the intent that the bot has, the message the bot wants to come back with, and figure out what words go with that intent. My work primarily focuses on the understanding side, but we're hoping to expand into the generation side as well soon. From the understanding side, there's basically 2 tasks you had to do. One of them is figuring out what use case is this particular text about? Which question did they ask? Which dialogue do they want to enter? Intent classification is one of the most hard things to do. Then, if you continue on in the dialogue, sometimes you need a little more information to complete that use case. If they want to make a reservation, you need to find out, well, reservation from when to when. You need to figure out what kind of room do they want. So you start asking them questions. You put them in the response role. And now you need to extract the data from their responses. You need to know which answer are they providing me so that I can continue with this task. So there's a lot of different ways of going about this from the technology side. And I could go way deeper into this than any of you want to hear, because this is my research area for the past 20 years. But under the surface layer, right, we have the typical classifier, which is what we call the bottom-up classifier, starting with data. So if you have an enormous amount of example sentences that your customers would use to express different intents, then you can train a classifier to say, okay, these are the different sentences I've seen in the past. Train this classifier so that when I see new sentences, it can figure out which intent it belongs to. So it goes from the data up to the classifier. An alternative is a top-down approach, which says, okay, can we try to build a classifier that matches our data? Again, we still need to have some examples of how people are going to express themselves. But we're also going to leverage some linguistic AI that will help make those classifications. But we're still building something that is going to say, given a sentence, how do I figure out what they're trying to say? And the reason why we need linguistic AI is because it is very difficult to figure out from the surface what exactly maps to what. So here we have two incoming sentences, and if you can't see it, it's one person saying, I want to transfer my data, and another person saying, how do I move my files? So they're asking an IT question. There are almost no words in common between these two sentences. But you and I know that this is basically the same use case, because we know that transferring and moving are related ideas, and we know that files are a kind of computer data. So this really is about the same use case, even though the words are very different. And if I had trained a classifier on examples like the one on the left, it may not recognize that the one on the right is the same thing. And it may get confused about the fact that a sentence that's almost like this one that's now in the middle, how do I move that to my file, is actually about inserting an object into the file, even though almost all the words are the same. So what we need is something that is smart enough to see the relationships between the first two and the differences between the second two. And that's why one of the approaches that we use at Aspect really looks into linguistically what is going on in the sentence. And when I built this example for another talk, I didn't think forward to the fact that if I'm presenting this in the UK, this example does not work as well, so I apologize. In American English, check, meaning the piece of paper that you write to promise a payment, is spelled the same as a verb or a noun. But here's the two example sentences here. I need to cash a check, and I need cash, so can I check my balance? In both of these examples, we have two key words, cash and check, showing up. And in American English, the check is spelled the same way. But in the first example, cash is the action they want to do, and check is what they want to do that action to. In the second example, cash is something that they are requesting. It's a noun, and checking is the action they want to do. So if we're smart enough, if our AI is smart enough to understand the linguistics of what's going on here, knows what nouns and verbs are, and can look at the sentence deeper than the surface, it can see that these things are not the same. Another thing we'd love to build into our AI is the idea of some world knowledge. So I'm told that emotional support animals aren't as much of a thing in the UK as they are in the US right now, but you have a lot of people wanting to bring their animals with them and saying, I need this animal with me, and so can I bring this animal to my hotel? And the reality is, there are some interesting choices that people are making for their emotional support animals. Now, we don't want to have to train our AI that a question about a gecko, or a question about a ferret, or a dog, or a bunny rabbit. We don't want to have to train all of those examples so the AI knows animals. This is about animals. What we want is to have the AI already be able to have this world knowledge that there are thousands of animals in the world. And I don't care what kind of animal they're asking to bring into this hotel. If it's not a certified service animal, it's not allowed. So we want to be able to build a classifier around that kind of intelligence. So we don't have to provide those examples and teach it. So just to summarize these two different ways of going about this particular task, right? We have the big data approach. The bottom up really requires a lot of data to get started. If you have the linguistic AI that you can leverage first, you can start with a lot less information, and you use those linguistic abstractions. You use your linguistic AI to capture the diversity and the different possibilities that people might bring up, like all these different animals, or in one of the projects I worked on recently, and we want to be able to do searches on lots of different kinds of wine. I'll talk about that in a second, to be able to know all of these things are different kinds of wine. One of the advantages to having that top-down thing is the ability to inspect what logic your system is using to classify intent. If you want to know exactly what reasoning it has learned from the training, work with a top-down environment and you get that inspectable classifier. And also, if you want to fix it, if it's not doing what you want it to do, then with a top-down system, you can actually tell it to do it differently rather than providing it with more training data and try to convince it to do it differently. Okay, so here's where I was talking about wine. Quick show of hands. I know it's before lunchtime. Who here loves wine? Okay, keep your hand up if you're a wine expert. Not really. Okay, so you're going to the store and you're thinking, you know what? I've gotten the same kind of wine every week. I'd like to try something different, but there's a lot of options. I don't know what to do. So this is a system that we deployed this year on Aspect Technology. Margot, the wine bot. Has anyone heard about Margot, the wine bot? Hey, look at that. We're in the press. So Margot, the wine bot, was deployed by Little UK to help people with their wine purchases. So you might say, well, wait a minute, how is this a contact center question? So think of the people in the grocery store or in any retail store as sort of the first level of your contact center. They may not be on the phone, but they are the people that your customers are talking to in the field with questions about what they're trying to purchase. And in the case of Lidl, they had great success with wine in their stores. They've got over 800 of them here in the UK, but very few people in the store who actually know wine. So people have questions about wine when they're shopping in the store, they have no one to talk to. And they want to figure out, well, we have expertise. We have the people who actually choose the wines and write reviews for the wines for Lidl. How do we share that to our people who are in the store? And the answer was, well, can we put an AI that will help with your wine choices on every mobile? And so they worked with us to build this, and the great thing is, like I said before, this scales. If it's 10 o'clock in the morning and nobody's buying wine, then you're not paying for a staff person to be there to ask questions about wine. Or maybe they're picking up wine maybe somebody picking up wine for that night, and they are there at 10 o'clock in the morning. If there's 10 people in the store all wanting questions at the same time, then Margot could be there for everybody. And Margot does food pairing. So, I've picked this up for dinner. This is what I would like to eat tonight. What goes really well with this food? Margot also does wine selection search. So this is, I'm interested in a red wine from Italy, but I'm not interested in paying more than 10 quid. What do you have on the shelf? So asking for a query on what's currently available in stock according to certain criteria. And then on the fun side, she also answers FAQ questions. So people ask questions like, oh, I got red wine stain on my trousers. How do I get those off? How do I get that clean? She'll answer the question. She answers, what makes wine sweet? How does a sweet wine become sweet? I don't know. And so she'll answer various questions about how wines are. She'll also quiz you on how much of a wine expert you are. So if you think you know something about wine, you can go head to head with her and see if you know as much as she does. You might notice, if you look at the screen grab, that here I say that I'm the natural language processing person and I do natural language processing R&D, but there are buttons on that screen. Buttons aren't natural language, and you're right. We do have some of the interface by buttons because it's faster than typing, and unlike human language, it is totally unambiguous. So for certain things, it's nice. If there's a small number of choices you have and you want to not have to do the work, why not take advantage of the fact that there are this button interface in Facebook, and when they press on food pairing, we know that that's exactly what they want. We don't have to worry about that. But it doesn't work for everything. So we have over 200 different foods that Margot can provide recommendations for, and to go through a menu system or a button system to get to what food you want advice for, that would take forever. Also, for frequently asked questions, first version of Margot answers, I think, about 15 questions about wine knowledge in general. But even 15 questions, that's going to be several layers of buttons to get to, and we want to expand her to answer a lot more. And follow-up questions. So somebody asks, well, what goes well with chicken? And she gives a recommendation. Now you want to know, well, what wines do you have that meet those criteria that I could buy? So stay there long enough so that Dan can take a picture. Okay, so as a result, we don't just do natural language input, we do diverse inputs. So we handle buttons, we handle emoji, because, you know, millennials buy wine too. They're old enough now. Individual terms, what we call in linguistics telegraphic input. So telegraphic input is when people drop words out of their sentence to make it simpler and faster. It is goes all the way back to people sending telegrams and not wanting to pay more money, but people do it in texting. And we have to be able to handle that. And we also have to be able to handle people who talk to Margot in full sentences. And linguistic AI has to be smart about the fact that people use lots of words for certain concepts. If I ask this audience, what is this item in the upper left-hand corner? They'd probably say chips, but I would say French fries, right? Well, we have to allow that there may actually be an American shopping at Little UK who wants to ask what goes with French fries, although wine with French fries is an odd combination. And we want to know that it means the same thing, and we don't want to have to train the AI. Here are the possible different words someone would use. Let's have that built into the linguistic intelligence of the platform, that there are lots of different words, including someone could just say fries, that all mean the same thing. And from the burger perspective, you know, people could say hamburgers. I was told yesterday that people saying hamburgers around here are people who are trying to sound American. That they would ask for a hamburger at McDonald's. I had never heard the term beef burger before I worked on this project. So apparently that's more of a UK term, but the idea being that those are all the same thing. They're synonyms, they're built in. And also, we know that people make spelling errors, and we don't want the AI to be stupid. I mean, you know, if you are dealing with Alexa and you're speaking, she's probably going to have difficulty if you mispronounce something. But we want our text environments to be robust to the fact that people could misspell something, and she should be able to recognize it all the same. And the other intelligence that is built into our platform and into Alexa is this idea of domain ontology. So I brought this up from the perspective of the animals, right? We want the hotel bot to be able to answer the question about any animal and not have to teach it about specific animals the way Margot uses domain ontologies with food. So she has a specific recommendation for pasta, and then she has an even more detailed recommendation for if someone says, I'm having pasta with marinara sauce. But if somebody mentioned fettuccine or ziti as part of their meal, and there isn't a specific recommendation for fettuccine, thankfully Margot has the intelligence to know that fettuccine is a kind of pasta. So she'll give that pasta recommendation. So if there's a specific one out there, she will give the specific recommendation. If it's not, she'll back out to a more general one. So there's a general recommendation for chicken, a general one for beef, but more specifically there's recommendations for coq au vin or roast chicken, so specific dishes within larger ones. And it's all built into the ontology. A lot of that ontology already exists as part of the platform. Some of it we co-developed with Little while we were working on the project. And we worked a lot on her ability to answer these open-ended natural language questions, which is something you have to teach the AI. You can't just start off with saying, you know, just give it some data and say, be intelligent about how to answer these questions. You have to work at it. You have to think about, well, what are our customers going to actually ask? We always tell people start small when you're building out the answering. If you don't have data on what questions people typically ask, what you think is the frequently asked questions may not be the frequently asked questions. We also need to wonder how will they ask them. So we worked really hard on crowdsourcing. How do you express yourself? how do you express yourself? What are the different varieties that people use to express themselves? Because if you don't have reams of data of people asking this question in a text channel already, you're going to have to collect at least some to get started. And then continue to work on that and develop that over time as you see the patterns. And that's one of the things that I do. I look at the data, I look at the logs, I see what the patterns are emerging, and we develop out to meet those. And the great thing about Margot is that she really made a splash in the press. I was absolutely jazzed that they talked about us on BBC Radio 4, and we've been in the newspapers, and we've been in a lot of trade journals. People really enjoy Margot. Now the funny thing is Margot isn't the most complex chatbot in the world, but she's fun, and it has really done something to engage the customer base and get them thinking about Little. And she's going to be expanding, and we're continuing our relationship with Little.